Alright, since we've got the Julie back, we're going to get started on this. It's good to see you all. How you been doing? I hope you're all doing well. You're at home. Thank you for those of you who've been trying to go into Khan Academy or IXL to get some of this figured out on your own. My goal is going to be usually that these Google documents are designed to help you with those Khan Academy or IXL assignments. So hopefully you see what we're going through here kind of overlaps with the first few Khan and IXL assignments. First things first, we kind of want to pay attention to key terms. A lot of this as we start talking for the next week about volume and about area is going to be about understanding the names of these shapes and some of the key terms. Michaela, Fatumata, it's good to see both of you in the chat now too. So first things first, you're going to want to understand that a radius, and you should have heard this term radius with Mr. Neville last year, that refers to the distance from the center of the point of the circle out to the edge. And then diameter refers to the distance all the way across the circle if you go right through the middle of it. So as you notice, the diameter is always going to end up being twice as long as the radius, and that's why one of the formulas I'm going to write down on the whiteboard, which is 2 times the radius is equal to the diameter, is probably the last formula that's not on our worksheet that you kind of want to pay attention to. Anytime you have a diameter, divide it by 2 and you'll get the radius, or if you have a radius, multiply it by 2 and you can get the diameter. Circumference is our word that refers to the perimeter of a circle. It talks about how far is the distance all the way around a circle to get back to where you started. And if you might remember, if you do circumference for any circle divided by the diameter, that's going to give you pi, which is the reason for our first formula tells us that circumference is always equal to pi, which is 3.14 or thereabouts, multiplied with the diameter. As we mentioned earlier, the diameter is twice as big as the radius, so you have the radius, you can do 2 multiplied with the radius multiplied by pi, and that will also get you circumference. Later on, as we get into problem 2, we'll start talking about the area, how much space a circle takes up. For the first problem, we're focused on radius, diameter, circumference. For those of you we have here with us on chat, is there anybody who figured out for the blue circle what the radius, the diameter, and the circumference is? If you want to chat with us right now, if you want to explain it, and Christina, good to see you in the chat. Is there anybody who figured out for this blue circle what the radius, the diameter, or the circumference needs to be? Feel free to put that in the chat if you know. There's a slight delay, so I'm going to give you a minute. Is there anybody who wants to type into us what they think the circumference, the diameter, or the radius for this first blue circle would be? And Gabby, good to see you too. I see Gabby says 4. What does the 4 refer to? Is that going to be the radius for the circle? Is it the diameter? As we see from Marcus, 4 inches is the radius, so that's what we were looking for on the radius. And based on that, does anybody know what the diameter or the circumference for the blue circle is based on a radius of 4 inches? And I do agree with Julie that the radius is 4, so we're thinking now what would the diameter be for that blue circle? Michaela says the diameter is 8. Yeah. And Marcus says, yep, so a bunch of you are seeing if I take the radius and I just double the radius, that's always going to give me the diameter. The slightly more complicated question, and you might remember this from Mr. Neville last year, is if I know the radius or the diameter, how can I find the circumference, the distance all the way around that circle? So before you tell me the answer, I'd almost be more curious, what could I do with the radius or with the diameter to find circumference? On my whiteboard, I'll start to show you how I would think through this. So I'm going to put the whiteboard a little bit larger right now. And if I need to find circumference, understand that circumference is always equal to pi times the diameter. So if circumference is equal to pi times diameter, and I know the diameter is 8, I could do pi times 8. Which is the same thing as 3.14 times 8. And as we work for the next week, 2 weeks on this stuff, use calculators all the time. So if I do 3.14 or pi multiplied with the diameter, that's going to tell me what the circumference is. So is there anybody who's got the circumference? If you're looking for a quick way to use a calculator, Google is always a calculator. If I type 8 and then the asterisk, that's for multiplication times 3.14. I see a bunch of you already 25.12. Michaela's got 25.13, so she's probably using a more exact version of pi. 3.1415, as you remember, it keeps going. So for us, if they tell you to use 3.14 for pi, and with Khan Academy being a little annoying and specific, make sure you use exactly 3.14 and not the full pi. So that would get you to 25.12. Based on that, is there anybody who thinks for the next question, which is really the red circle, they could identify some of the dimensions? And to Julie, thank you for pointing that out. I actually had that there, the coronavirus tab, which I'll switch over to since you mentioned, to highlight that if you all go to bostonpublicschools.org/coronavirus, that's the name for their website that has all the resources in the city, and also shows you, if you click here, beyond the Mildred, remember at Mildred and lots of other places, 8:30 to 11:30 every day. Oop. I'm a novice with YouTube. We'll show you full screen there. If you go into that website, coronavirus.org, the first link kind of takes you to all of the free meal places around the city, and remember that's from 8:30 to 11:30. I'm going to close that off now, though, and kind of go back to our work here. So, I'm with Marcus. Marcus sees that the radius for the red circle is going to be 9 centimeters. And is there anybody who wants to provide other information? And Kev, it's good to see you in here, Kevin. I assume tough like Kev is Kevin Meridian. So good to see you, buddy. So if the radius is 9 for that red circle, I'm looking for somebody to identify either what the diameter is or the circumference is for that red circle. Anybody know for the red circle what our diameter or what our circumference would be? Diameter is 18. I'm with Christina and Marcus on that. So then at that point, I'm going to put the whiteboard a little bit larger. Once I know the diameter, I know circumference is always equal to pi multiplied by whatever the diameter is. So in this case, the diameter is 18. So using circumference is always equal to pi multiplied by the diameter. If I know the diameter is 18, 18 times 3.14, which is what we're using for pi, is going to get us $56.52. I see from Christina, Fatu, a bunch of you. Awesome, awesome, awesome. So yep, the circumference is 56.52 inches for that red circle. For the green circle, anybody want to talk to us about what they believe for the green circle? Let me fix the whiteboard there. What do we believe the dimensions for that green circle need to be? I'm not going to do out the green circle with you all. Instead, I'm going to wait for people to have answers for the green circle in our chat. I think using our circumference equals pi times diameter formula, and understanding that diameter is twice as big as the radius, for this green circle you should be able to figure out all 3 of these on your own. I'm with Michaela. Thank you, Michaela and Marcus. Yep, the radius is definitely 1.5 feet for that green circle. And I think you found that based on the diameter being 3 feet, so I'll put that 1.5 feet for the radius. Diameter is 3 feet. I think we all see that going across. And that's going to leave us with a circumference. I can use the diameter and plug that right into our formula of pi, 3.14, times the diameter of 3. Lilo, it's very good to see you. Welcome to the chat. If you take a look at what I have right now, we've been working through the first couple problems together. Lilo mostly using that circumference is always equal to pi multiplied by the diameter. So if I take 3 and I multiply 3 by 3.14, I get to the same answer I'm seeing with Christina, with Gabby, of 9.42. I think Marcus is 9.43. He's probably actually using the exact pi. So if I were to, maybe that's what gets him up to 9.43. If I use 3.14 for pi, I'm going to get exactly 9.42. And Jamari, I finally got a win in Fortnite last night after about 5 straight days of no wins. So maybe I'll come watch you to learn a few tips. Yeah, some of this is starting with us. A TBD, Jamari, stands for to be determined. So TBD stands for to be determined. The trickier one here for problem 1 is probably the last one. So for the last circle, you see they provide you with the circumference. And they say that the circumference is 12.56 inches for that circle that's kind of orange and blue and red colored here at the end. I'm curious if there's anybody who could explain to us in the chat, how could I find the radius or diameter if they provide me with the circumference of a circle? Again, how could I find radius or diameter when they finally give me the circumference? I'm going to show that on my whiteboard too if I don't see anything yet, but I definitely would like to hear if there's anybody here in the chat with us who could figure out how to go from circumference in a circle and figure out what the radius or diameter had to have been. Alright. Yep, so Fatu, Marcus, they're right, they're getting that division. I'll show you on the whiteboard at least my view why I think it's division. Here we know the circumference is 12.56. So if I'm looking at that whiteboard and I put in 12.56 for C for circumference, and that's equal to pi, which is 3.14, multiplied with the diameter. A bunch of you remember peeling the onion with Mr. Neville or inverse operations. The way I cancel out that multiplied with 3.14 is I divide by 3.14. And by doing that, 12.56, which I'll show on my Google calculator, divided by 3.14. And yep, thank you to Julie, got to do division. And that gets me to diameter must have been equal to 4, because if we had done 4 times 3.14, that would have given us the original 12.56 for circumference. So if I take circumference and I divide it by pi, circumference divided by pi, that ends up telling me my diameter like we saw on the whiteboard. And then if I know that the diameter is 4, I could also figure out what the radius is. I think a bunch of you already know anytime I have diameter, I just cut the diameter in half to figure out what the radius is, because radius is halfway across the circle. So like Christine is saying, hopefully a bunch of us had recognized that the radius would be 2, and yeah, I see. Oh, Ariel, welcome. Thank you for joining us, Ariel. And a bunch of you with us there. So thanks for being patient, as there's a bit of a delay before I see your chat show up between when my streaming actually shows up on YouTube and we see your chat, so thanks for the patience as we kind of go through a 5-10 second delay sometimes. So that works you through how to go from circumference to radius, or from radius to circumference, working with diameter and radius. Hopefully, if you're thinking through Khan Academy, I'll just show us quickly. The first couple assignments on Khan Academy are based on that. So if you're thinking about the first 2 assignments on Khan Academy, you should now be prepared to do that based on radius and diameter. That wasn't helpful for me to tab over, I'm sorry. Same thing with IXL. I think the first 1 or 2, hopefully you're ready for now. The second thing we're going to move in together as a group, we're going to do problem 2 as a group. And problem 2 is now going to shift from talking about circumference, and circumference measures the distance all the way around a circle, to area. And area is going to measure for us how much space that circle actually takes up. And a bunch of you may remember, I'm going to put this onto my whiteboard now, your formula from Mr. Neville last year for the area of a circle. We'll scroll back to the top of the document. The area of the circle formula is area is equal to pi times radius squared. So I'm going to copy that formula onto my whiteboard. Area is equal to pi times radius squared, and that's our key to finding area for all these problems that involve area of a circle. And to Julie, if you need a Chromebook still, let's chat after this. The BPS is providing Chromebooks to students. There's a form you need to fill out, so I'm going to email that form over to you at the end of the chat and then try to post something on Classroom for everybody for that. But if you didn't get a Chromebook and you don't have a good Chromebook at home to use, there is a way to still get one from BPS, and we'll share that. Alright, so for the first circle, we see it's an orange colored circle on number 2, and they ask us to find the area of that circle. Is there anybody who found the area of the circle and wants to share that in the chat? Christina says 9.42 is the area, and I think she's definitely thinking already about this area formula. What's the radius for the circle? The radius is 3, and if I did do 3 multiplied with 3.14, that would get me to Christina's 9.42. But I think it's important to see for our area formula for the circle, it says the area, or A, will be equal to pi times the radius squared. And in our case, we see the radius for this orange circle is 3. So if the radius for the orange circle is 3, we're going to have to insert a 3 for r, for the radius. So the formula becomes area is equal to pi multiplied with 3 squared. And if we remember order of operations, before we multiply the pi with the 3, we're actually going to square 3 first. And 3 squared, 3 times 3 gives us 9. So if we're using this area formula, we're going to get area equals pi multiplied with 9. And if we do pi times 9, and they say we could use 3.14 for pi, when we take 9 and multiply that with pi, 9 times 3.14, a little over 27, is going to give us 28.26. So you could have said two things here. You could have said 28.26, and that's if we decided to use 3.14 for pi. So again, if we decided to use 3.14 for pi, we multiplied it out, we get 28.26. Another option that we could do is you could write, lose the caps, you could just write 9 multiplied with pi. That's the option where it says provide an exact answer using pi. So one option, another correct answer in addition to 28.26, would be to say 9 pi. People have questions about that? Can we see where 28.26 comes from? So again, both of those would be correct answers, 9 pi or 28.26. And if that makes sense, I want you all to try to take a couple minutes here and work out for the purple circle, what does the area need to be for the purple circle? If you want to provide an answer in the chat after you kind of work out the purple circle's area, that would be great. Again, there's probably 2 correct answers, one that uses pi in the answer, or one that uses 3.14 for pi and multiplies that out. So I'm going to give you all a couple minutes again to try to work through the purple circle, to try to find the area for that situation. And I see Lilo's already working through the first one. Lilo, I would ask you, what did you use for radius in this area formula? As I look at the purple circle, and I was a bit of a pain in the neck here, what is the radius going to be for the purple circle that we need to use? I see an answer of 113.04 from Michaela. I'm going to start showing on my whiteboard. I think Michaela probably used, yep, and I see from Marcus 113.04. I think both of them used a radius of 6, seeing that if the diameter is 12, the radius must be 6. Half of 12 is 6. And then they take that 6 squared, which becomes 36, and they multiplied that with pi. So Kevin, for you, you're going to want to go to Google Classroom. And then when you're in Google Classroom, I'm going to show you pretty quickly here. you're going to want to click the classwork tab. And at the top, Kevin, then you need to click into the digital lesson 1 and actually click view lesson here. And if you go ahead and click view lesson, it might take a couple minutes if you don't see the Google document or view assignment, and you should see your Google Doc pop up there. I gotta go back to the lesson. Alright, so a bunch of them use pi times 36. That's what we'll go back to showing on the whiteboard here. And if we do pi multiplied with 36, you're going to get that 113.04 that we saw from Michaela, that we saw from Marcus. And Charlize, I appreciate that. I care about you as well. So again, 113.04 would be one correct answer here. Or alternatively, you could have written it in terms of pi. You could have said 36 pi as your answer. And that also would have been a correct answer. So I think at this point you have the skills you kind of need to do the red circle, or maroon, whatever color you want to call that, and the light blue circle here as well, which is really a semicircle or half of a circle, you'll notice. So I'm going to again pause for a little bit in terms of any work that I'm showing here. And I'm going to wait in the group chat until somebody starts saying, hey, for the red circle, the one that has that diameter of 5 feet, I think this is the area. Or for that blue semicircle, what the area for that is. The other thing is you're working through these two problems, or these last two parts of problem 2 on your own. If you've ever got questions when you're on Khan Academy or IXL on your own, feel free to send me an email. Feel free to, I'm going to try to have Jamari help me figure out some type of chat. How many do we have watching to Julie? I didn't pay attention to that. 14, so that's good. It's great to see 14 of you here working. Lilo's coming up with 19.62 for the red one. I haven't done the red one yet. You get 19.625 for Michaela. If we did 2.5 times 2.5 times 3.14. I'm with Michaela. Michaela was the most exact at 19.625. If you were going to stop at 2 decimals, we probably should have seen 19.63 technically if you were going to go there. If you're going to round it to the nearest hundredth, then I need to start specifying where to round to. You'd go to 19.63. But I'm with Michaela. Thank you for being very exact there, Michaela, and coming up with 19.625. And great job for all of you who saw for that when the radius had to be 2.5. I'll show that quickly on the whiteboard, but I think most of you are there. And if we took 2.5 and squared that, we had 6.25 for the number that needed to multiply with pi, which got us to that area of 19.625, in this case, square feet. The last one's a little trickier. We see it's a blue semicircle, or half of a circle this time. Your job is to find the area of that blue semicircle. I'm again going to keep pausing, let some students work through this. And then if we see answers coming up in the chat that look correct, I'll kind of show at least how I ended up at that same correct answer that some of you all found. The blue is 314. I see a lot of students with 314, and that means you're thinking you're using the formula, but you're also not thinking about, is this a full circle? Is this part of a circle? And how would my area formula need to change a little bit, or what would I need to do to the area if this is not a full circle but just part of a circle? So if this were a full circle, we would have area equals pi r squared. We would have a radius of 10 inches, and we could plug in a radius of 10 inches. But that would be for a full circle. And if I did do that out, I'd get area equals pi times 100, because 10 squared does make 100, and 100 times pi does make 314. If I do 3.14 times 100, it just moves the decimal twice, like a bunch of you saw. But this is not a circle, this is a semicircle, so the area formula needs to be changed a little bit. A semicircle is exactly half of a circle. So I'm still waiting to see in the chat, what would the area in square inches be for this half or semicircle that's blue? And I see Michaela's got 78.5. And I'm guessing, Michaela, did you cut the 10 in half and you said the radius was 5? And then if you did 5 squared, you'd get 25, and 25 times 3.14 would be the 78.5. The 78.5 is an interesting answer, and it tells me Michaela's the closest so far. But the radius would not change from 10 inches to 5 inches if we had half of a circle. If we had half of a circle, it would still be a half circle with a radius of 10 inches, but the total area, the final product, would be cut in half. So what do I need to do with that 314? I'll go ahead and start showing this on the whiteboard. If it's half of a circle, the area is going to be pi r squared divided by 2, or cut in half at the end. So I'm still going to use a radius of 10, and I'm going to put the whiteboard into full screen here, or a little larger so we can see that better. If it's half of a circle here in blue, I'm going to use pi r squared divided by 2, which gives me pi, still times a radius of 10 squared, but at the end, after I get the area, I have to divide by 2 because it's only half of a circle. So based on that, I get area equals pi times 100 divided by 2, or area equals 314 needs to be divided by 2. And that gives me a final answer for the area of the semicircle of 157. There you go, hopefully we can see the end there. Yep, the area is going to equal 157. And I see that popping up for a bunch of you who probably had that 157 before me, and it's just kind of the delayed video streaming that happens. So that's going to give us an area of 157 square inches for the blue semicircle. And if she's trying to learn and she's figuring it out on her own, I don't think any of it's cheating. And yes, I'm with Kevin on cutting it in half to get down to 157 at the end there. Alright, so here's the deal. There's 3 more problems for you to practice on your own after this. Let me fix the stream a little bit. One second. Alright, so you're going to see 3 more practice problems that are a little more challenging but build on those ideas. I would say for number 3, if you think back to the first problem, the very last one we did there where they gave you circumference, you should be ready to do number 3 on your own. For number 4, again, based on our second problem set, you should be good there. For number 5, I think number 5 is more challenging than what we've done. So I'm going to stick around here for a few more minutes. I think number 3 and number 4 I'm not going to go over as a group. But if you've got questions for 3 or 4, you could chat with each other, you could email me, but that's really what Khan Academy and IXL are going to practice as well. I think right now you should try to do number 5, the PhD level problem. In this situation, oh, that's what Jamari kept asking me about, is number 5. I didn't put an area in there. So, I messed up the 5th problem a little bit. I'm very sorry about that. I had meant to put something in there, and I did not. Let's see. If you want to do number 5, I messed that problem up pretty badly. You're going to have to look at my stream right now. And on my stream, I'm switching that problem to say the circle has an area of 1,256 square inches. And it asks, what is the diameter for that circle? So that's the last problem we're going to do together. I'm going to give you a few minutes to do on whether you've got a whiteboard, a piece of paper, anything you can do to try to work out. If they give me the area for a circle, and I know the area formula is area is equal to pi times radius squared, could I figure out what radius produced an area of 1,256 square inches? So again, I'm going to give you a few minutes to work that out. I think this problem might take a couple more minutes, but if I give you the area formula for a circle, which we have already, area equals pi r squared, and they tell you the area for some circle is 1,256 square inches, what we see here. Try to figure out how could I determine the circle's diameter. And to Julie, to answer your question, there's not going to be summer school. No. I've seen nothing that would suggest they're going to have summer school in order to try to make up days. I think their goal is for you all to be learning at home while this is going on. And so hopefully the 16, 17 of you here with me right now are learning from home on your own. Some others are doing the same. But I don't think there's going to be any summer school. So I'm going to give a few more minutes, and then in the chat, if you want to say, hey, I think I figured out how to do this problem, the last problem, or if you want to say, hey, I'm stuck, feel free to give me some feedback there. DJ, very good to see and hear from you, buddy. If you're coming in late, DJ, and we're just seeing you now, this should be recorded, so if you go back to my YouTube channel at the end of this, then you should be able to watch the whole recording from the beginning. You'll have to fast forward to the first 10 minutes when we're not really doing math yet. Michaela, I don't think there's going to be MCAS this year. The state of Massachusetts has not given an announcement yet. And if you all have other questions, as some kids are working on problem 5, you can definitely keep typing those questions in like Julie was and Michaela was. But I don't think you'll have MCAS. I can't say that for certain yet, but I would be very, very surprised if the state makes us take MCAS with what's going on. You guys should be sad. You would have done well on MCAS. You should be saying, I don't get to show off everything that I learned. I'm sad. Benji, very good to see you too, buddy. Glad to have you here. Because this 5th problem shows up on Khan Academy a little bit, the 3rd assignment specifically has this show up, I think, on Khan Academy. I think we're going to be doing a lot of school at home, Gabby. I'm hopeful that we come back together at Mildred for the last month or two, but yes, we're going to be doing a lot of using Chromebooks and trying to connect for math, at least here, and then ELA, we'll probably see what you're reading on your own and different things for group projects. Jalen, I was late too. That threw it off. It took me like 15 minutes to figure out how to stream correctly. You should, Janae, if you log on to Khan Academy, you should see like 7 assignments that are sitting there. And to Julie, yeah, if you stayed home on Monday, that's probably a socially responsible choice anyways. Thank you for continuing to try to stay in as much as you can. As Ariel, thank you, Ariel. Really good point. Jalen, you'll be able to watch this from the beginning. You could even, now that it's recorded, you could even speed it up and skip through parts that you understand, but it should be recorded so you can see if you're coming late. And Janae, I would say at least 2 to 3 days a week. If you all like this, and especially if there's 10, 15, 20 kids who are showing up and working on some of the math, I'm definitely happy to do this every day. My plan at first was a few days a week, and then a couple days where I would just kind of be available to help you with Khan Academy or IXL. But at least a few days a week, I'm happy to be streaming, kind of showing a small group document like this. And then we can also use some kind of video chat too if you guys have just got questions about IXL Khan Academy that are more individual and specific. Alright. That's awesome. Tell my age I said hello as well. I hope she's doing well, and I hope you're doing well, John A. Alright, so is there anybody who... Kevin, I'm going to text Miss Neville right now and tell her that you're reading and talking about how much you enjoy doing her homework. So, no, you need to be reading. You need to be doing the Miss Neville stuff. She'll probably be in contact with you to show you updated work, too, as we go over the next couple weeks. Jalen, you're probably going to be in luck. We think there's probably no MCAS, but the state of Massachusetts hasn't said anything. But that would be my guess, is they end up canceling MCAS this year based on us being out of school. We'll see. All right, is there anybody who figured out problem 5? I know it's messed up in your document. It says TBD, like Jamari was pointing out, so you've got to add the number 1256 in there. I kind of messed that part of the lesson up today. So if you add 1256 square inches in for the area of the circle on number 5, is there anybody who was stuck, who can't figure out the diameter? Is there anybody who has any idea? Is there anyone who thinks they got all the way to the final answer there? And again, this is going to be the last one we do together. I think if you've done problem 1 and 2 and they make sense. Janai, very good to see you, buddy. And Janae, I think most kids, even those who are here with us, are probably going to get stuck on number 5 because we didn't show any examples of how to go from the area to the radius or diameter. Janae, what you're going to want to do is go back to the beginning of the video after we kind of leave this chat in a second, and that's where we talk about circumference, diameter, radius, how to work that stuff out. Mrs. Watson, yes, if we come back to school, you should expect to see Mrs. Watson in school that last month or two. Hopefully, if we get to go back to school April 27th, you should expect to see all of us teachers there then. Alright, so like I said, we had a bunch of people who came in a little bit late. That's totally fine. At the end of this video, at the end of the stream, you're going to be able to go back and watch it from the beginning. There's like a 5-10 minute chunk where I'm not doing math, so feel free to fast forward through that. You can also email me directly if you've got questions, or use it. Hopefully some of you are getting familiar with Google Chat or GChat. I usually have my Gmail up, so you can also send me just a direct GChat or an email, and then I'll log on, and that's an easy way to get some direct help on math if you're working IXL or Con. Alright, so for this 5th problem here, I'm going to put the whiteboard a little bit bigger. We know that they told us the area of the circle is 1256 square inches. So this formula can also be used to help me work out what the radius must have been to produce an area. And if I know the radius, I could figure out the diameter. So I'm going to plug in 1256 for the area, or for A, and 1256 is equal to pi times radius squared for this circle. Jalen, I'll answer your Miss Neville question in a little bit too. I can post some of her stuff online to my classroom probably. So if I know that the area is 1256 and that came from pi times radius squared, then the first thing I probably need to do, if you're thinking peel the onion, is this 3.14, this pi that's multiplied with r squared, is the outer layer that we need to peel. And the opposite of multiplication is division. So if I divide by 3.14, that would cancel out pi from the right side. And 1256 divided by 3.14 gives us exactly 400 if we use a calculator. So 400 is equal to r squared. The radius must have been, when it was squared, equal to 400. And this is where square roots help us out. If you remember, the way we solved the x squared equations was to take the square root. If I take the square root, that will tell me what number squared makes 400. And if 2 times 2 is 4, that means 20 times 20 is 400. So when I do the square root of 400, I should already be expecting to see an answer of 20. That tells me the radius must have been 20, and a radius of 20, when I do 20 times 20, that gets me 400, and 400 times 3.14 puts out that area, 1256. So again, this is a bit more of a challenge problem. I do see that popping up on the 3rd Khan Academy as like the last challenge question kind of, so I wanted to show you how to find a radius if they provide the area. But the big thing hopefully a lot of us took out of this is the key for working with these circle formulas is understanding the vocab, that r stands for radius, that d stands for diameter, and how to use these formulas like circumference is equal to pi times diameter, or area is equal to pi r squared. It was really awesome to see you all. I'm going to sign out now. I got to go eat some lunch. But it was great to see you all. I'm going to stick around for about 30 more seconds. If you've got any other questions, feel free to put them in the chat. Feel free to hang out here, guys. And Jamari, if you're still around, I'd love for us to figure something out. A good app or some website that can be used to kind of just chat more interactive where we see all your faces and some of the work you're doing. So again, I'll stick around for 30 seconds and you're going to see me stop the stream if we don't see any more questions. Thank you for everybody who came by and is working on math. Most importantly, I hope you're all staying safe, doing well in these kind of weird times. We'll be fine, we'll get through it. Just keep hanging out inside and keep doing some reading and math while you're at home. Oh, Michaela, I did mess up. The diameter should have been, if we knew the radius is 20 inches, the diameter should have been 40 inches. And Marcus at most would do this like one time per day, but if you're doing IXL or if you're doing Khan Academy, Marcus, at other times and you have math questions, you can definitely send me an email or use GChat, that Google Chat feature. You should see me online. Janai, you want to just keep doing the work so that you're learning, so you're growing, so you're ready when we come back to school and you're ready for high school and that starts. I'm not going to get into what's going to happen if you're not able to do the work while you're at home, but I think you're ready to do it, so keep doing the work at home. And to Julie, be nice to the old people like me who are losing in those games. It's not fun when you keep being the guy who loses in those video games. Alright, if there's no other questions, I'll see you guys later. Thank you for everybody who showed up.